Hello and welcome to my office. Today, we're going to be talking about how to analyze Annexin V PI staining in FlowJo. Let's take a look. All right, as you can see here, I have my samples already populated into my workspace, 2 different time points, 24 hours and 48 hours with various concentrations of the treatment used. Now, when I'm doing my Annexin PI analysis, I generally start with my untreated cells. One thing to be cautious of when you're setting your first gate is because you are eventually looking for cell death, you don't want to exclude the potentially dying cells out of your cells gate, like I know a number of people do when they set this. So you really want to make sure when you set this gate that you're setting a nice broad gate that will capture any shifts that your cells undergo as they start to die. So specifically, as they start to move with a lower forward scatter and a higher side scatter. Getting rid of the doublets is the same. So we'll do area versus height. Again, single cells, doublets. So we'll get our nice doublet gate set along there. Whoop. And then go into our Annexin PI stain. So in this case, I had Annexin V and normal PI. Ooh, axes look a little crazy. Let's just that a little bit. Zoop, zoop, zoop. And get around a little bit of space on this one. Zoop, zoop, zoop. I liked it better that way. Okay, so you can see down here we have a nice population of viable cells. We're starting to shift over here a little bit towards the annexin stain. And then up here we have our PI cells, or PI positive cells. Now, the thing I find most challenging with Annexin PI analysis is you always have this population of cells in here that have PI staining above your background, but have not necessarily the same level of PI staining that you see in the really, really dead cells. Now, having run these samples on an image stream, which allows me to look at the PI staining, I know that these cells generally have PI staining inside the cytoplasm, but the staining hasn't yet reached the nucleus. So the cell membrane is compromised enough that the PI can get in, but the nuclear membrane is still intact. Because of this, I've generally set, that's the wrong one, my axes a little bit more conservative and gated like this. Because when I'm analyzing my PI, the way I like to look at it is that it is in the nucleus. It is staining the compartment in which I am intending it to stain. However, you may make the argument that these cells would also fall into the PI category because they technically have PI inside the cells, and you may want to set your gates here. Again, either is valid depending on your question and the logic that you've used, and as long as you apply those gates consistently from sample to sample throughout your experiment, again, any changes will be comparatively reflected in those gates. I'm just going to move them back up here where I like them. So now that we have those gates set, we're going to apply these gates through our entire population. And I like to then just do a quick scan in my layout because I find this the most straightforward way to look at all my samples. So let's get a little batch report going here. So what you will notice, we'll zoom in a little bit here. You can see as my cells get treated, I start to see a shift in my annexin population moving slightly over this way, as well as up into this PI area. Now you'll notice that this boundary may not quite exactly reflect those populations. So let's take a look down through the rest. It looks pretty good here. So I'm pretty happy with where those gates are outside of a couple samples where we have a little bit of a transition state towards the annexin. But as we start to see our cells really die, you can see that those gates are nice and clean and capturing those populations appropriately. So from this point out, it's getting your data out and doing your subsequent analysis, which is the second question I get a lot of with Annexin PI analysis is which population do I report? And again, this is going to depend on your question and on your experiment. So for this series of experiments, we were looking at how the cells were dying, and specifically if we were seeing differences in the annexin and PI stains over time with the treatments. And so in this case, I reported my data as the percent annexin positive, the percent double positive, and the percent PI only positive. However, I've also worked on other projects where the question was, what percentage of my cells are alive? And that's the only part you really wanted to know. You didn't care how they were dying. And in this case, you would then report this statistic, your quadrant 4, or your double negative population. So again, a lot of this comes down to your experiment and what you need to get from it. So there you have it, gating Annexin V PI samples in FlowJo. It's fairly straightforward, fairly easy to do. You just need to be cautious with gate placement to make sure you're doing it consistently across your samples and being decisive as to how you want to capture that PI signal. And secondly, thinking hard about your scientific question and which statistics out of your FlowJo software are going to help you best answer that question. And with that, keep those comments coming. I'm happy to provide you with more FlowJo details on whatever your experimental issues may be, and we'll see you in the next one.